There I am. Good evening. Welcome. Thanks for joining our diagnostic training session today. I'd also like to have a shout out to Ephraim, my buddy down in Rockville, Maryland. He's got a bunch of people watching in a shop down there. So thanks for watching. Thanks for tuning in. If you do have any questions throughout this presentation, if you're watching on Zoom, just look at the top of the bottom of your screen, wherever your Zoom controls are. You should see a Q&A box. You can click on that, type in your question, hit submit, and I'll get to those at the end of the session. If you're watching us live on YouTube, then just use the live chat function wherever it is on whatever you're watching us on, and I'll get to those at the end as well. So my name is Jason Gabrinas. I'm one of Snap-on's National Diagnostic Technical Trainers. Been in the training department the last 9 years or so, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple years as a diagnostic sales rep with Snap-on, so I had about 30 different Snap-on franchisees I worked with, as well as the shops that they serviced, in order to help everyone get the most out of their diagnostic needs. Then before I did that, it was 8 years at Subaru. So worked in a Subaru dealership, and I guess over time became the Diag guy in the shop. So I always ended up with the drivability problems, the intermittent problems, the weird wiring problems that would show up on those cars. Certainly a lot of those, not just head gaskets every 60K. And before that, a bunch of other miscellaneous wrenching jobs. Been a little over 25 years underhood experience for me. So our topic today is going to be component testing. We're continuing our component testing series that we've done over the last couple of years. And tonight it is diesel fuel injectors. So gasoline and diesel, there's similarities, of course, but there are differences between the two types. So we're going to talk about, well, differences between gasoline and diesel engines to start. And then we'll talk about the different types of fuel injectors that they use in the diesel world. Now, as far as the diesel world, we are sticking to the up to maybe 1 ton, maybe F450, maybe something like that. So generally the ones you're going to see in automotive shops if you're working on those. And if you're not working on them, maybe it might be something else you might want to work on. And we are going to be focusing on, of course, North America, because that's my scan tool set up for. I know over in the UK and Europe, and there's a lot of diesel cars over there that have, and they have engines we don't have over here. So won't really be talking too much about that. It's mainly going to be based on trucks, as I said. We're going to go through gasoline versus diesel, GM and Dodge common rail injectors, then the Ford HEUI injectors, Piezoelectric injectors, which a lot of manufacturers have gone to nowadays. So by and large, those will operate pretty similarly. And then we'll go live on the tool and talk through different scanner functions we can do with it on different vehicles, and some scope testing through the guided component test as well. So let's talk about, well, what's the difference? So gasoline versus diesel. Of course, we know there are some differences, but there are some similarities. They both need the 4 same main ingredients to run, right? They need air, they need fuel, they need compression, and they need an ignition source. Notice how I didn't say spark, because diesel doesn't use spark. It has an ignition source, which would be the compressed air. Air is going to be the same, but how they use it is different. So gasoline engines will use a throttle body to control the air going into the engine, and that's going to therefore control the amount of fuel being used, which controls the RPM. Diesel engines, however, do not use the throttle body system. The RPMs are controlled by the amount of fuel being used. More fuel in, goes faster. Most modern diesels make use of a turbocharger as well to compress the incoming air, so we get even more compression in there. And in turn, we're going to burn more fuel to make more power. So these turbo diesels can get a lot of power coming out of a relatively smaller package. The fuel is going to be different. So gasoline is a petroleum-based product that is more refined than diesel. So it also has less energy available during combustion, and the auto ignition temperature is higher, so about 475 degrees Fahrenheit. Diesel, on the other hand, is also a petroleum product, but it's not as well refined as gasoline. So it has more energy available during combustion, and its auto ignition point is lower than gasoline, 410 degrees Fahrenheit. So that's what we use that for, to ignite the diesel. Compression is going to be different too. So gasoline engines compress a fuel and air mixture before igniting with a spark. Compression in a gasoline engine is generally 100 to 150 psi per cylinder. Depends on the manufacturer, of course. Diesel engines use the compression to compress the air charge before the fuel is mixed in. So superheated air then ignites the fuel. So if we can get that air compressed to more than 410 degrees Fahrenheit, then we're going to get combustion as soon as the fuel hits it. Compression in a diesel engine can be 500 psi or more per cylinder. So we're dealing with much greater compression there as well. And as we talked about earlier, ignition is going to be different. So after compressing the air and fuel mixture on a gas engine, that needs an ignition source. So your spark plug, your wires, your coil. Generally a coil of some sort, spark plugs, both running at high voltage to ignite it, 10, 20, 30,000 volts to jump the gap. Whereas with a diesel, after compressing the air in the cylinder, diesel fuel is injected into the cylinder and auto ignites due to that high temperature of the highly compressed air. When you compress air, temperature goes way up. Diesel engines do not need an external ignition source. That's not what glow plugs are for, right? Glow plugs are to preheat the air that's in there. So maybe I am on a cold day and I need to get a little bit of a head start. So it heats up the air before we compress it, makes it just that much warmer when it's time to ignite the fuel. So combustion in a gasoline engine, as we've seen many, many times, you get the spark plug in there, you get the flame front, the spark ignites it, flame front pushes down the cylinder or the piston in the cylinder. Whereas on the diesel engine, really the piston is the combustion chamber itself. So it sprays into the piston in that smallest possible area they can get. So it's a moving target. In a diesel engine, only air is drawn into the combustion chamber. Fuel squirted into the combustion chamber only when it is time to burn the fuel. It has 0 degrees of crankshaft rotation to blend. If you look at the plumes of fuel being squirted out of the injector here in the middle, you can see that they go into the pockets. And it's going to be a very lean mixture at the surface of the plumes and very rich in the center of the plume. So it gets considerably more lean out towards the outside and richer towards the inside. So that problem can be minimized by high fuel pressure, multiple injection pulses, and combustion chamber turbulence, but it's never eliminated. So we will have some striation in there. And if you remember, we talked about striation in our direct injection gasoline class, because it works on a similar principle between the diesel and the gasoline direct injection. So like we said, the piston head is shaped to create air turbulence in there, and it squirts it in right at the last second, going up and down, pretty much right at the last second at the top of top dead center before it starts turning back around. All right, so let's talk first about the common rail injection that they use on GM's Duramaxes and the Dodge 5.9 and 6.7. What it does is it uses high pressure fuel provided by a camshaft driven pump, and it is electronically controlled. Each injector has electrical connector and high pressure fuel. So as you can see here, we have the fuel tank down there where the diesel would be, and then that feeds into the high pressure pump, and then the pump runs off the camshaft. It's got a little eccentric on the camshaft that pushes up and down, causes it to pump it to a much higher pressure, sends it to the fuel rail, that common fuel rail there. It does have a pressure limiter, and then it runs on back to the tank after that. So we have the each individual injector is getting high pressure fuel fed to it. And then, of course, it reads off the air mass, coolant temp, air temp, boost pressure, accelerator, pedal, engine speed by cam and crank as well, feeds into an electronic control unit. And that is how it knows when to fire the injector. So that part of it, pretty similar across the board, gasoline, diesel, direct injection. Doesn't really matter what kind of injectors it is. The computer needs to know when it's time to fire it. So it's low pressure coming out of the tank, much higher pressure coming out of the pump. And then we can see the interior of the injector. So we got fuel return here, and high pressure comes in on the side. So we have this ball that's a check ball, and it's hollow in here, hollow in pretty much all the whites. So we have a valve spring in there, and we have this closing the pintle down to the nozzle. It's a high pressure there. The fuel actually keeps it closed. The fuel flows in here, pushes down on this piston, and keeps that closed. When I want to open it, we use the electromagnet up here, which is going to be on the top. It's going to pull up on this, the pilot here. It's going to pull up on that, allowing to bleed off some of the pressure of the fuel. The spring then overcomes it, and it pushes up and comes down and allows it to spray out the bottom. So always high pressure fuel here. Just a matter of, do we let it bleed off on the top to go back, or are we using it to keep that closed? So there's a couple different ways that operates. Fairly simple, really, if you think about it. We use the high pressure fuel that's already there, and uses it to keep it closed, and that pops off like a pop-it valve, right? So a couple different, if we wanted to measure the current there, we got the current. So you got a high current at the beginning, then a hold current, and then it drops. Whereas on the lift, we see we get up to our full lift there, and then it drops off after the current drops off. So we need the high current to get it to move. But once it does move, then it can stay steady just by keeping a steady current on there and then dropping off at the end. And then as far as pressure in the chamber versus pressure in the control chamber, we can see we got less pressure there, less pressure there, more pressure there. And then the rate of injection goes up. So we open it. And then when it finally does open, about 0.35 milliseconds. After it finally opens and the fuel can spray out, we can see the rate of the injection down there. So a lot of stuff going on in order to make this work, but that is how that works. It is very, very high pressure. Very, very high pressure. Now we get to the HEUI, hydraulic electronic unit injection. So as we said, we want this high pressure fuel. So in this case, they use on the Ford Navistar, the Power Stroke 7.3 and the 6 liter. So the old ones. And it uses high pressure motor oil to magnify the fuel pressures. Instead of sending high pressure down there, it uses the motor oil to actually push down on a piston and increase the pressure. So it's electronically controlled as well. Each unit has an electrical connector, low pressure fuel, 45 to 65 PSI, and then high pressure oil in the 3 to 3,600 PSI. So this started back, way back in the the 90s, 94.5 to 97, 7.3 uses a mechanical lift pump. And then it also had moved to an electronic control unit, 99 to 03, and then 03 to 07, 6 liters as well. Fuel supply pressure is higher than an engine's used in conventional injection, but ranges, as we said, from 45 to 65. So here's an overview of that system. We have the high pressure pump that's down in the valley here, and we have a high pressure branch of the oil. High pressure standpipe there, high pressure oil rail, injection control pressure sensor, and the fuel injector over here. So those are the base parts of the system. And then here's what one of those looks like. So we have a solenoid on the top, high pressure motor oil there, low pressure fuel goes down around the ball. So the main components are going to be the solenoid, as we said, on the top, and then we can see all the innards here. The oil chamber, which is where our high pressure oil is going to reside. Poppet valve that's going to pop open and allow that oil to bleed through. Intensifier piston, which is going to intensify the pressure coming out the bottom. Fuel chamber, which is going to be in here. So remember, we have low pressure fuel, so that pretty much makes a circle all the way around. And then the nozzle down here at the bottom. So when the electronic solenoid gets energized by the FICM, so that's the fuel injection control module, it pulls the poppet valve off the seat. And because it's held out to the lower seat by a spring, we see the spring up here. So it pulls the poppet valve up, the solenoid pulls this up, and allows the high pressure fuel to come in here. Closes off the oil drain pathway and opens the inlet for high pressure oil to come through. So we can see the high pressure oil coming in here, and we can see it sitting this orange right here. There's the solenoid, there's the oil chamber, there's the pop. The intensifier piston down here has 7 times more surface area than the plunger, which means 3,000 PSI of injection control pressure converts to 21,000 PSI of fuel injection pressure down the other end at wide open throttle. So that's a huge intensifier just looking at that. 21,000 PSI. That's a lot. So it pushes down, increases the pressure here, which overcomes the spring pressure once again. We had a spring pressure here, overcomes the spring pressure, sprays out. The high pressure oil on top of the intensifier piston forces it down, which in turn forces the nozzle needle to lift, pressurizing the fuel in the plunger cavity, and ultimately opening the nozzle, sending fuel into the combustion chamber. So as we see, fuel's in here, much higher pressure now with the intensifier piston, pushes it down there, which overcomes the spring pressure, which sprays it. There we go. When the injector cycle is complete, the solenoid de-energizes, closes this back down, doesn't allow any more air in there, and allows the oil to bleed off the top. The intensifier piston returns to where it was. The fuel pressure is now too low to overcome this spring pressure, and it holds the nozzle closed. So it's a mechanical injector. Mechanical injector runs out, well, electromechanical. So we have the electromagnet solenoid up here, but the intensity of the pressure is intensified by a mechanical action or hydraulic action. Hydraulic action pushing this down, which is mechanical action, which increases the pressure, overcomes it. Then we went to common rail injection on Ford 6.4s and 6.7s. High pressure common fuel rail, once again electronically controlled, and each injector has electrical connector, high pressure fuel, and piezoelectric coils. Like we said, a lot of manufacturers have gone to this piezoelectric coil roundabout when Ford did it, plus a little bit after that. So piezoelectric coils, piezoelectric injectors have their piezoelectric activation in here. We're going to talk more about what that is and how it works, of course. We have stroke amplification, so it has to be able to amplify the distance that the piston travel. We have hydraulic control down here, and then we have fuel atomization down the end. And of course, on the top, we have a solenoid. So we have this piezoelectric stack here. And what it is a bunch of wafers. And when we apply electricity to those wafers, it makes them move. So this works on a very similar principle to how a knock sensor works, just in the opposite direction. So if we apply electricity to it, they move, or if they move, they produce electricity. So that's how a knock sensor works. That's got a little piezo stack in there, and when it moves, it generates electricity. So works both ways, just we're using it differently on this side. So when I put electricity there, makes them expand, and then we remove the 12 volts, they come back, apply 12 volts, it expands, comes back, expands, comes back. So we can see how it's causing the stack to move, pushing this piston. Piston's not moving all that far, but it's moving. So that brings us to this guy right here, the stroke intensifier. So we got a spring here, we got a little nub, and then we have another nub over here. And that uses the same type of principle as our oil-fired injectors that we saw before. So we got a spring in there. So we got this little piston here. It's going to be pushed on by that stack. The stack's going to push on this, which is going to push on this, which is going to have fluid in here, which is going to push on that. And then since I can't compress the fluid that's in there, it's going to push on this. So you see how it's just kind of sitting there right now. But when we add diesel fuel in there, it then ties them together. So if there's no fuel in here, it's just going to sit there moving back and forth. When fuel gets in here, it's going to push. It's going to tie them together, and we're going to have a longer stroke down the other end. Because we can't compress that fuel too much. All right. So here's the end of that assembly there. So it's going to end up pushing on this in here. So use that high pressure fuel. It's going to push in. So when it's able to overcome that spring pressure, it comes down into the this little valve here. And when it pushes down, it allows it to once again overcome the spring pressure, brings the needle up, sprays the fuel. We're using an awful lot of that fuel overcoming the spring pressure idea here. So it pushes on that to closes off the escape and allows the pressure to come up. And then on the nozzle end, we can see a little bit more detail with that. There's a spring. There's the fuel. Fuel pressure in the control chamber and the tension of the spring keep the nozzle needle closed. So it's pushing on this, pushing on this. And then when it's able to bleed off, when it's reduced, it's going to bleed this fuel off out of here. And it's going to allow it to get around and spray down, spray out. Gasoline injector, piezoelectric injector will work on the same principle. So now that we know how they work, let's look at a few things we can do using scan tool and scope. So I know we got a couple different types of things we can do. So first one I want to do is I want to pull off, start with the old Ford there, 03 F350. It's going to have the 7.3 in it. The first thing I want to do is look into guided component tests. What can I test in my guided component test system? So if you have a snap-on tool with the scope, so a Zeus, a Verith, a Verdict, a Triton, a Modus, any of those tools, a Vantage, any of those tools will have this database. Otherwise, you can just use repair information, and you can use your any old scope and be able to check it as well. But if you have one of our tools that has this database in here, it's going to make life a lot easier because it tells you a lot of information. So we got injector control pressure is going to be related, injector pressure regulators related. But if we go into fuel system here, we got fuel injector and fuel pump. So I'm going to go to the injector. And for that, we can do a resistance test. So HEUI injectors, hydraulically actuated by high pressure engine oil, supplied by high pressure oil pump. The injector has three main components, which contribute to the higher injection pressure. First component is electrohydraulic injector amplifier piston, which operation is controlled by a solenoid operated popping valve. The second component is electrohydraulic injector fuel plunger, which has been driven by the amplifier piston and injects high PSI fuel into the combustion chamber through the fuel rails located in each cylinder head. The third high pressure oil system that is controlled by the PCM powertrain control module through IPR, which is injector pressure regulator valve, and is monitored by the PCM through the ICP injector control pressure sensor signal to provide proper oil control and fuel PSI operation. Now, over here we get to our harness. Now, this is where we may have some issues on some of these vehicles. So we have a harness side that shares the glow plugs and the injectors with that. So the best test location in this case is at the valve cover wire connector. So the wires actually go into the valve cover and they're sitting in there attached to the individual injectors which are under the valve cover. So the component is under the valve cover and it says best place to test at the valve cover gasket inboard wire connector. So you got to take the valve cover off and check it at the connector. Now, since it's sitting in oil, bad things can happen. We can have breakdowns of our insulation. We can have breakdown. I mean, these things are made of plastic. Connectors made of plastic. You sit long enough in oil, high temperature oil, it's going to get a little crusty, right? So key off, disconnect the connector at the valve cover. So in this case, we're doing a resistance test. We're going to measure resistance at the injector. Injector resistance should be less than 2 ohms. Always check connections between valve cover and the plugs as well. Okay. So that's one test we could do there. Fuel pump test we could do as well. So the fuel pump's an inline electric pump mounted on the left-hand frame rail in this case, and then we have our power and ground. It's externally located in the inner part of the front vehicle frame rail assembly, and the best place to test the connector. We can do a DC voltage test on that. So we will check it at pin 1, check for battery positive. And then a resistance test, same type of thing. We're going to pull the harness, should be less than 5 ohms in the harness. Let's see what we can do in the scan tool on this, because there is a test that actually was created due to that problem. So we go in here under engine, and we go into functional tests. There is this injector buzz testing. So the injector buzz test, what that's going to do needs to be done engine off, AC off, all accessories off, if equipped. And what it's going to do is it's going to buzz the injector. So verify the keys on, don't start the engine. And that will verify that the injectors are all working. So first thing it does is it buzzes all the injectors at once. So it's basically just actuating all the solenoids. You can hear them buzz. When they buzz, it'll then buzz individual injectors. So if you hear one, you miss one during the 8 injectors, that's the one you're going to want to look for. So it's going to give you codes at the end. In this case, I'm running a simulator, so I'm not going to have anything happen. It's just going to kind of sit here for a while, so I'll just exit the test. But it will give you codes in there when it's done. So it'll buzz it, and then it operates a self-test, and then it'll show you what's going on. I think to exit, I need to exit the vehicle. That's okay, because we're on to our next vehicle anyway. Next one's going to be a newer Ford, Piezoelectric Injectors. 2019 F350. Okay. Series. There we go. So once again, we can go into the engine and go to functional tests. And let's see what we got for special functions. So we have a bunch of DPF stuff. We got fuel injector quantity adjustment. So if you weren't here for the beginning of the pre-roll video there, we talked about fuel injector quantity adjustment. This is pretty common on a lot of vehicles now, especially with these piezoelectric injectors. What you need to do is you need to tell the computer what the flow rate of that injector is going to be, especially if it's new or if you swap them around, you need to change that as well. So in this case, it's a 10-digit code on the top, and don't confuse the characters like 8 and B, D and 0, etc. We're going to go through here. On the next screen, we're going to record the codes and then select the injector to be programmed. So here's all my codes displayed in this simulated vehicle. Let's say I replace the injector number 1. I can go in there and edit it. And we can do something like maybe 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. That's 10-digit code, right? Verify it's correct. Hit OK. It's going to give you the old number. It's going to give you the new number. Hit program. And it's going to program it. Easy enough, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Easy enough. Quick and easy, but you need to do it because if you don't do it, it's not going to run right. What else we got? Programmable parameters on the engines. That's just tire size in there. So people ask me where to find that. So it's actually inside the engine's tire size. Power balance test is another one you can use though. So this is in park or neutral. Excessive RPM or rapid RPM changes may cause data loss. This will disable the fuel injector compensation strategy and make sure the parking brake is engaged and the wheels are chopped. Continue. And it's going to look a little funny because we're in a simulator, so we got some weird stuff going on. But it's going to look very similar to the Ford test down here. It's going to give us a line graph. So it's going to say, how is that cylinder contributing? So the lower number is bad. Higher number is not that great either. We really don't want to have overcompensating on the high side. So that's kind of an anomaly. You probably wouldn't see that on a real life car. What you would see, though, is going through the middle here, these relatively flat ones. And honestly, on a good running vehicle, they're going to be pretty darn flat. Not going to have a lot of variation at all. But a nice thing we can do is we can turn off the injectors individually. Now, in this case, we can just cycle through. You're not going to see anything happen because we're on a simulator. But if I did injector 1 and it was flat and then it went down, we know that it's not contributing anymore. And maybe that's the bad injector. Because remember, we don't have ignition on these vehicles. So if I turn off the injector and it stays running like garbage, then it's probably the injector. You can enables them all back, and then we would see that come back up. So we're able to do injector kill and have this power balance all on one screen, which is kind of nice. And I'm pretty sure somebody told me that the Ford tool, you have to do 2 different tests to do injector kill and the power balance. So we have it all in one. It's kind of nice if you're working on this. All right, let's go and look inside. Got a component test on this one. Go 6, 7 on that. So you can see coolant temp, ECM, oil temperature. Let's go into fuel. Injector, pressure control valve, relays, pressure sensors, temperature sensors, fuel pumps. I'm just going to go into the injector here. These are normally closed solenoids responsible for delivering atomized fuel in the intake manifold ports. Coil inside the fuel injector generates in a magnetic field. 6.7 diesel fuel injector uses a piezo actuator to electrically control the injectors with extreme precision. Piezo actuators turn on for approximately 0 to 400 microseconds, or in that case, millionths of a second. Microseconds, millionth of a second for 2 injections. Piezo actuator is a composition of piezo discs that, when electrically energized, cause the disc to deform, resulting in an expansion. This expansion results in a longitudinal motion, thus controlling the injector. We saw that in the animation, so it moves that piston out. Pushes downward against the valve piston. Actuators return to its non-energized state via engine control module, switching the polarity electrical feed to the injector. We can see the pin assignments here. It's just a 2-wire injector. Here it is at the control module where we'd find it. Best place to test them is at each injector on the inline harness connector if available, mounted in the intake manifold above each cylinder under the fuel injector rail. Some V6 or V8 engine may not be accessible due to the manifold, and mounted on the cylinder. Okay. So we back up. We can do a voltage test and a resistance test. So we can go in here. We can check the voltage, and what we should see is, got to come down here a bit. If the measured voltage should be greater than 10.5 volts, proceed to the next step. Check fuel for contamination. Carry out sufficient clean fuel test. If not, repair the affected circuit. So it should be 10.5 volts or more. So really, it should be alternator voltage. Resistance test should be 150 to 210,000 ohms on that injector, that's pretty high, but pretty standard for piezoelectric injector. All right, so that's the Ford. Oops, I'm going to go in here actually. Let's see. Next one's Chevy Silverado. Don't want to leave our GM buddies out. So as far as scanner functions, we go into functional tests. We got DPF tests, output controls here. Output controls, we can change the regulator pressure, fuel pressure control as well. Fuel heater, that could be related. Reductant injector, that's not the fuel injector, but a bunch of different things related in here. Fuel injection data resets. as well. If I go into cylinder power balance, that is going to be similar to that Ford balance test, except I can do individual injectors. So we're just going to go in here, and it's going to be one injector at a time that we can turn on and off. So we can disable and enable, and then we can just release the control, put it back the way it was. Let's see on guided component tests, because this one should have piezo injectors as well. 100. Fuel injector. A lot of stuff in fuel. Line pressure sensor, fuel pressure, fuel pump. Fuel injector, though. So this is a momentary high current to open the injector. At the point there is virtually no current flowing, and the injector stays open until the current reverses polarity to close the injector. So that's the same thing, 400 to 650 microseconds. It is a piezoelectric injector. Turns off very rapidly. We can spray multiple times per injection stroke. And best place to test it's at the connector. So if we want to do a signature test, don't get shocked. According to GM, the voltage is supplied up to 160 volts at 20 amps and can peak up to 240 amps. So you need to be very careful with that. Do not make contact with the fuel injector harness, ECM, or fuel injectors while the ignition is on the on or run position. They want you to use insulated gloves similar to what you'd use for an EV or a hybrid vehicle. You want to also wait 5 minutes after the key is turned off to allow the capacitors to bleed off as well. So on the signature test, it's going to show us what it's going to look like. If we come down here, we have a known good. Right, so there's your on and off. It's going to have 2 pulses. You may also see a control side, a sympathetic control, and it's going to see multiple pulses there. Current ramp, what we're going to see is we're going to use a low amp probe to do this. And if we get all the way down the bottom here, there we go. Going to put it around one of the control lines, and then we'll see current goes up, current levels off when it's open, staying open, and then current goes down to shut it off. So open, flat, close. So positive and a negative. Be careful with that too, doing this. So it should be 10 to 12 amps at idle. But what you're going to want to see is you want to see it go up first. If you see it go down first, your probe's probably on there upside down. Because current is directional. So if it's flowing in the direction of the arrow that's on your little low amp probe, it's going to go up. If it goes in the opposite direction, it's going to go down. So if you see it the opposite of that, where it goes down then up, either invert your pattern or flip your low amp probe over. So you can see the current flowing up and down. If it doesn't go down, it's not closing. If it doesn't go up, it's not opening. If it doesn't go up, it's probably not going to go down either. It's probably going to be flat. So just so you're aware of that. And then, let's see. Not to leave out our RAM folks, we'll go and check a RAM. Got a component test again. Let's see, it's a big one, right? Diesel. There we go. Engine, fuel. So the injector on these is going to be very similar. Piezoelectric. Supplied by the injection pump through high pressure fuel line into a fuel rail through high pressure lines through steel connectors to the solenoid activated fuel injector. Actually, this is a common rail. Powertrain control module actuates the solenoid, causing the needle valve to rise when fuel flows through the spray holes and the nozzle tips of the combustion. Provides both power and ground. So that's actually one of the common rail ones we talked about earlier. Resistance test should be less than 0.8 of an ohm, above 0, but less than 1 if measured directly at the injector. Less than 0.8 of an ohm measured at the harness. So those are low resistance. And then as far as scan tool functions, got to wait for security link, of course. Okay. Engine. We got functional tests. Got lift pump. System tests. Going to go in here. We're going to find injector kill tests. That's the same type of deal. High pressure fuel system test, fuel system run up test. Different things that you might need to use for the fuel pressure and the fuel injectors as well. And then miscellaneous. I don't think there's too much in here. Let me see. I'll reset injector compensation values. So that's in there. stationary DSOT if you have to do a DPF. And the last one we're going to look at is Mercedes Sprinter. So the Sprinters are pretty popular. We see them all the time out there on the road, especially saying Amazon down the side is pretty popular with them. For these, though, we're going to have a very similar type idea going on with the piezoelectric injectors. So we do need to do injector programming on this. So it's key on, engine off. And in this case, they use a QR code. So it's essential to save the QR code of the new injector in the engine control unit. Process ensures the necessary correction parameters for the injector will be recorded in the engine control unit. These correction parameters enable the engine control unit to meter the injector quantity precisely. In this case, it is a 7 character. On the Ford, remember, it was a 10 character. So it's going to be different every manufacturer. And then we have this here. So just edit this. 1, 2, 3, 4, 5, 6. Hit OK. Oh, it's 7 code. That was right. I just said that. Okay, there we go. So there's my old code. There's my new code. Program it in. All done. There you go. 1, 2, 3, 4, 5, 6, 7. So it's pretty easy to do, like I said, but it does need to be done on all of those things. So it might be a value here. Let's see. Not really anything we need for that. A lot of DPF stuff on it. And then as far as guided component tests, it is going to be, go to the fuel injector again. In this case, it is 140 volts, also controls the ground side. These are the direct injectors again, and they are the piezoelectric injectors. So it's going to be pretty much the same thing. Just be wary, high pressure fuel lines on these as well, 23,000 PSI, pretty high. So make sure it doesn't leak because that's going to hurt. And high voltage, high pressure. So not the best combination in the world. Also does give you a tech note down here. Anytime a new injector is installed or if an existing injector is installed in any location other than its original location, the injector quantity adjustment procedure, also called injector classification, must be performed. So we're telling you about it here as well. In this case, we want to replace the copper seal ring every time, retaining torque geared bolt and torque to yield bolt. Lubricate the body of the injector with nickel anti-seize or malachite anti-fretting paste. Install tensioning claws, tighten fasteners, 62 pounds, then 180 degrees. So it gives you all that information just for the injector right there. Resistance test, signature test, current ramp test going to be pretty much the same. Let's see what the resistance is. Let's see, should be 400,000 to 600,000 ohms on these. So these are higher resistance than the other ones we were looking at. So it just depends on the vehicle, depends on the manufacturer, what we're going to be seeing there. We always have the connector views. What we need to see. And oh, by the way, when you hit view meter, automatically sets up the voltage, it sets up the time, or sets the range for, in this case, we're looking at ohms. So it's going to set the range for you automatically. So that's another fun thing. So we don't have to worry about thinking about learning how to set up my scope because it set itself up. Pretty cool. All right. So hopefully we learned a lot about, or at least a few things. Might not learn a lot, but maybe you did. Hopefully we learned a few things about diesel injectors, how they work, how we're going to test them, the different functions that we might need to use with our scan tool as well to go through operations. Now, I have an exciting announcement. I announced it last week, but not a lot of people watched. So on my software stream. So we are giving away an epic chance to win an epic prize. So, and this is like the easiest contest to at least get entered to win. I'm not going to say you're going to win. It's the easiest one to get entered. And if you're not in North America, sorry, we don't have a contest, or at least this isn't this contest. You may have a contest going on over there, wherever you might be. But for North America, so that's US and Canada, anyone that upgrades to 22.4 will be entered to win one of 10 Zeus Epic Diagnostic Workstations. So it's a 36-inch Epic cart with a hutch. Got a Zeus inside, docking station, 27-inch touchscreen on the back. It's like our riser kit. And it's super easy to get entered. Oh, yeah, by the way, unique custom wrap, personalized with your name on it, too. But it's super easy to get qualified because all you have to do is have your scan tool on the fall software update, which will say 22.4 on the bottom of the tool, or on the home screen of the tool, by the end of the year. So if you're already on software subscription, just install it. You're good to go. If you got a prepaid data plan on a Fast Track Intelligent Diagnostic tool, just install your software update when it tells you you need to have a software update. Or if you're out of date, talk to your franchisee and they can help you out. So any tool, any Snap-on tool running 22.4, which would be the current fall software release, just came out this week, automatically entered to win as long as it's there before December 31st. So what we're going to do is a few days into January, we're going to run a report, and all the tools that say, hey, we're on current software right now, you're going to be thrown into a random drawing, and one per region in the US and Canada. So that's 10 Epic workstations. That is a crazy prize. It's worth $24,000 plus at retail. That is a crazy prize. And I really wish I could win it, but I can't. But you might be able to. All you got to do, like I said, you got to make sure your tool's up to date. If you got a Snap-on scan tool, get it up to date, and you will be entered to win another scan tool that's up to date. But hey, that's okay. That is a wonderful prize. So if you want to learn more about this, that 22.4 software, we have 2 more live streams that we're going to do. Next one's tomorrow, Wednesday, October 5th. And then we also have another one on Monday, October 17th, 8 p.m. Eastern. So you're going to have to go to the login page because it's different. So it's going to be on Zoom and YouTube, no Facebook. So you will be able to watch it on YouTube if you're subscribed, or if you want to go register on Zoom, you can do that. So I'm actually going to put this in chat for those of you who want it there. I'm going to put it in chat here as well. There we go. So all you got to do is go there to register if you want to watch on Zoom, or like I said, you can watch it on YouTube, 8 p.m. Eastern for all of them. So Wednesday, October 5th, 8 p.m. Eastern is the next one. That's tomorrow night. And then Monday, October 17th, which is 2 weeks from yesterday. So we have a week we're skipping in the middle. And then, oh my goodness, so many announcements tonight. And then next week, we're talking about component testing. We talked a little bit about testing components, but we're going to get really deeper, a lot deeper into testing components and why do I need to test components? Why should I test components? We're going to talk about all sorts of different things, component failures. It's imperative that you have a way to test components, especially nowadays, the number of components on a car. So we're going to talk about that as a 2-part series. So next week will be week 1. Same time, same place, 6 and 9 Eastern. Go to snapon.com/OT to register for Zoom, or the 6 o'clock one goes to YouTube, youtube.com/Snap-on Diagnostics. If you are watching on YouTube, please make sure you're subscribed. It doesn't cost you anything. It just takes a click of the mouse. That way you'll know next time we release any new content. There's a lot of new quick tip videos have been coming out. And of course, the live streams too. You get a nice reminder that that's coming up. So definitely make sure you're subscribed over there. 9 p.m. goes over to Facebook. So it's facebook.com/SnapOnJason to check that out. If you want to see any of our past episodes, any of our past information, we talked about high pressure gasoline direct injection, which is similar to the diesel direct injection, evap systems, ADAS, data bus testing, all sorts of different modules that we can take, half an hour, 40 minutes long, just like this one. Once again, youtube.com/Snap-on Diagnostics. Check it out there. Now it is time for questions. So if you came in a little late on Zoom, all you got to do is find that Q&A box somewhere on your screen, type in your question, I'll get to those. Or if you're watching on YouTube, just make sure you use that live chat. While you're doing that, I want to make sure I mention my buddy Al, who also does free diagnostics training 3 nights a week. So he's Monday, Wednesday, and Thursday. On Monday, it's on Apollo. Wednesday, it's on Zeus, and Thursday, it's on Triton. So if you have one of those tools, or you have a buddy who has one of those tools, want to learn a little bit more about it, Al's your guy. So the first hour on any of the nights is going to be on whatever the respective tool is. It's going to walk you through. Let's make sure your Wi-Fi is set up, because that is critical nowadays. Have Wi-Fi set up on your tool. Then we're going to set you up with your free Snap-on Cloud account. He's going to walk you through how to do that if you don't have one already. Walk you through how to link your tool to the account. And then he's going to walk through code to completion, walk through the buttons and functions and features of Fast Track Intelligent Diagnostics. How does it help me diagnose a car faster, easier? That's the Apollo class, and that's the first hour of the Zeus and Triton. Since the Zeus and Triton also have guided component tests, he goes through another hour on guided component testing and the lab scope and all that after a 5-minute break. It's a very thorough class. Definitely worth your time. It's kind of designed to have the tool in front of you and watch it along on your screen, and then you can just click along on the tool, whatever he's doing on your computer there. So same time, same place, 5 and 8 Central Time. Go to Snap-on 6 and 9 Eastern. Go to snapon.com/OT. He only goes to Zoom. So you won't find it on YouTube. So definitely it's a little bit more of a smaller class setting so you can ask more questions. So snapon.com/OT to check. And with that, I'm getting ahead of myself. Let me get to my questions. All right. Looking on Zoom once again, Ephraim, let me know if you guys have any questions in the audience there. If not, we can continue. But definitely make sure you let me know if you do. Meanwhile, I got a lot of activity going on YouTube, so let's talk about that. So Quinn Hall says hello, hello. Hello, Nick from UK. Welcome. Thanks for showing up as always. Nick always loves his Snap-on Zeus. F. Bobby, good evening. Thanks for coming. Quinn Hall says, remember the wait to start glow plug diesels. Yeah, that's a wonderful thing. We're don't have to deal with that too much anymore. Bobby says, you mean like the two I worked on yesterday? Definitely still around, that's for sure. They're out there. They'll run forever, but yeah, let's see. F. Bobby asked, does it pulse them in numerical order or firing order? He was talking about the injector buzz test. And I'm going to be honest with you, it's been so long since I've done one, I'm not sure. But it does buzz them all, and it will tell you whether or not it passes at the end. So it'll say cylinder 1, pass or fail type of thing. So I don't remember. I know it buzzes them all first, and then it'll do them each in sequence. I don't remember what the sequence is. Let's see. Quinn is also very excited about that Epic workstation. I am too. I hope good luck to win. He also says regions as in north, south, east, west. So with Snap-on corporate, we have 10 regions in the US and Canada. So Canada's its own region, Northeast, Mid-Atlantic, Southeast, South Central, Central, North Central, Northwest, Southwest. So that's all our regions. So depending on where you fall in the country, that's where it's going to be. So one per region. So that is a ton. All good here in Rockville. Excellent, Ephraim. Thank you very much. Appreciate you tuning in. Bring your folks to come see this. And Neftali also says thanks from Rockville. He must be watching on YouTube as well. All right, looks like we have cleared the board. So thank you for your time this evening. Thank you for spending a little bit of time with me. Hopefully you learned a few more tips and tricks on diesel injectors, a few more capabilities that you may already have and you didn't know you had on your scan tool. If you want, you can join me tomorrow night for our software live stream. And then also, hopefully, you can join me next week for guided component testing part 1. So with that, enjoy the rest of your week. Enjoy your night. Enjoy your weekend. Take care.